Hi students, all of you welcome. Welcome to Sunil Engineering Academy. I am Sunil Kumar Bandaru. Students, in this session, we are going to discuss chemistry, important topic, chemical bonding. Okay, chemical bonding. And students, if you want previous sessions, just click on the playlist. You can find out the previous classes. Yes. Now, we are going to discuss chemical bonding. You know very well about bond or bonding. What is meant by bonding? For example, friendship is one type of the bond. Okay, marriage, that is also one type of the bond. Okay, so what this bond makes? This bond makes the two persons together. Okay, two persons together. In the same way, here also chemical bonding or bonding is nothing but the attractive force which holds the atoms together, is nothing but you can say chemical bonding. Okay, so same like real time. Note down here, bonding is nothing but the attractive force, the attractive force which holds atoms or ions together is called bonding. Okay, so in the chemicals we have mainly ionic bond, covalent bond, van der Waal bond, and hydrogen bond. That means approximately we have four bonds. In those, first two bonds are said to be strong. Ionic and covalent are said to be strong bonds. And in the same way, hydrogen and van der Waal bonds are said to be weaker bonds. Okay. So here coming to types of bonding. Types of chemical bonding. Chemical bonding. Okay. Here ionic bond, covalent bond, third one hydrogen bond, the fourth one is van der Waals force. Bond or van der Waals force. These two are said to be strongest bonds or strong bonds. These two are weak bonds. Okay. So if they are asking the question in the following, which is the weakest bond, that is van der Waals force. Okay. Now coming to these bondings, we have discussed each and every one. First of all, ionic bond, very important. Ionic bond. So ionic, as the name itself, ions. What are the ions we have? Positive and negative ions. So the bond between these two ions, that is positive and negative ions, is nothing but you can say ionic bond. As the name itself, bond between two ions, that is positive and negative ions, is nothing but you can say ionic bond. Okay, positive ions, for example metals, negative ions non-metal. So ionic bond is bond between metal and non-metal, that is male and female, like that. Okay, so here ionic bond is due to ionic bond is due to attraction between the positive and negative ions. Positive and negative ions. So positive ions, metals have the positive ions and non-metals have the negative ions. So it is bond between metal and non-metal. Okay. So second point, ionic bond is bond between metal and non-metal. Okay. So generally metals donate electrons. Metals donate electrons. Non-metals accept the electrons. So that means here metals are donating, non-metals are accepting. Non-metals are accepting. So that means here permanent transfer of electrons takes place. That means transfer of electrons takes place. Transfer of electrons takes place. Okay, so we can note down the point here. Ionic bond is due to ionic bond is due to transfer of electrons. This point is very, very important. Transfer of electrons. Transfer of electrons between metal and non-metal. Metal and non-metal. Example. If you take NaCl, okay, NaCl, Na plus Cl minus. So metal is the positive because it donates the electrons. Chlorine is a non-metal. Non-metal. Okay. So always these are trying to form octet. Octet is very stable state. Okay. For example, sodium atomic number is sodium atomic number 11. Correct. Chlorine atomic number is 17. Na? 17. So sodium 11 means it has 1s2, 2s2, 2p6, 3s1 it has. Here chlorine 1s2, 2s2, 2p6, 3s2, 3p, 2 to 4, 10, 12, 12 and 5. So that means to get a stable position, it has one electron is available here, but here to complete the outermost orbit, here it requires one electron. It requires one electron. If it having one electron, then it will becomes 3p6, which is stable. Okay, that means in the outermost orbit we have 2 plus 5 means 7. If it has one more electron, then total 8. So if it forms, in the outermost orbit, if it has octet, that means 8, it is going to be stable. Okay, so always the atoms are trying to form a stable state. And here in the outermost orbit, we have one electron extra. If there is no this electron, then second orbit we have 6 plus 2, 8. So it will form octet. So it will also becomes stable. So that's why one extra electron which is available in the sodium, that is transferred to chlorine. Okay, one electron transferred to chlorine. So electron transfer is taking place. Okay, so in that case this electron goes to here, then it will becomes in the outermost orbit 8. Okay, so this atom will becomes stable. So always the atoms are trying to form a stable states. Example, So you can take any example: NaCl, NaOH, KOH, the bond between metal and non-metal. Okay, metal and non-metal. So NaCl, NaOH, KOH. Not only with sodium and potassium, you can go with any other. Any other. For example, if you can consider calcium, you can take with calcium. If you want to take potassium with any other, potassium bromide, potassium chloride, okay, or NaBr, sodium bromide. Okay, like that we have bonds between metals and non-metals are belongs to ionic bonds. Now coming to the next one, the second one, covalent bond. Covalent bond. Here the covalent bond is due to sharing of electrons. Due to sharing of electrons. How it will be? For example, if we have two persons are there, A person and B person. Okay, A person and B person. Here they are very hungry, guys. They are very hungry. Okay, and here one they want to buy a biryani. Okay, the biryani cost is, let us take a 200 rupees. 200 rupees. There is no half biryani here. Okay, full biryani is 200 rupees. Here A having 100 rupees and B having 100 rupees. So if the A want to buy biryani, he can't buy. And if the B want to buy biryani, then also he also can't buy. Why? Because they have less money. But whenever they combined each other, whenever they combined their amount, then the amount will becomes 200 rupees now. Then they can buy a biryani and after that they can share. After that they can share half. Correct. So if they want to buy biryani, they are sharing their money. So in the same way, here also in the covalent bond also. For example, if you take the chlorine having, just now we have discussed na, chlorine having one electron requirement. One electron requirement here. Here another, if you take another chlorine, that also one electron requirement. In that case, they will share their electrons. They will share electrons and forms the chlorine atom, chlorine molecule, Cl2. Okay, so like in the same manner. So here covalent bond is nothing but the bond is formed due to sharing of electrons. Due to sharing of electrons, and it is said to be a very strong bond. Very strong bond. If they from this you can get idea, if there is no bond between them, then they may not share. Okay, they may not share. So that's why they have to maintain the bond between these continuously. Okay, so note down the point. This bond is formed due to sharing of electrons. Sharing of electrons between two similar or dissimilar. Similar or dissimilar or different atoms. Okay, and this bond is between two non-metals. Between two non-metals. Okay, and what are the examples you can say? Chlorine is formed. Chlorine is formed, and not only chlorine. If you can consider O2, oxygen, okay, or if you can consider HCl between the two non-metals, okay. So whenever there is a uh, bond between two non-metals is said to be covalent bond. For example, methane, NH3, ammonia, CO2. So all these are nothing but covalent bonds. In this covalent bond also we have single bond, double bond, triple bonds are also there. But that is not that much of important. The main important is nothing but these 2 points. The first point and second point. Okay, the bond is between the two non-metals is nothing but covalent bond. If you can consider single covalent bond, single covalent bond. Note of the points. When two atoms share one electron, pair, that bond is single covalent bond. That bond is single covalent bond. Example, the bond between two hydrogen atoms. Okay, and the second one, double covalent bond. Okay, here when two atoms share, when two atoms share two pairs of electrons, that is, that bond is double covalent bond. Example, here carbon dioxide, CO2. Okay, CO2. Carbon shares double bond between the oxygen, carbon and oxygen. Coming to the next one, triple covalent bond. Triple covalent bond. Okay, so here same. In this combining atoms share three pairs of electrons. For example, nitrogen. For example, nitrogen. Okay. Now the third one. What is the third bond? You can say hydrogen bond. Okay. Hydrogen bond. This bond is rarely exist. That is, this bond is only for hydrogen and other electronegative atom. Okay, so note down the point here. Note down the point here. The attractive force between a hydrogen atom and electronegative atom. Hydrogen atom and an electronegative atom. And electronegative atom. For example, chlorine, oxygen, nitrogen, it is. Okay. The attractive force between hydrogen atom and an electronegative atom is known as hydrogen bond. Okay, hydrogen bond. And so that means it is formed between hydrogen atom of one molecule and an electronegative atom of another molecule. Okay. For example, if there is a bond between hydrogen and fluorine, here between two non-metals, that is, it is considered as a covalent bond. Covalent bond. But if you can consider it is a one molecule, hydrogen fluoride. Okay, if you take another hydrogen fluoride molecule, now there is a bond between these fluorine and hydrogen. And if you take another hydrogen fluoride molecule, there is a bond between this fluorine and hydrogen. So that means this dotted lines bond is nothing but hydrogen bond. Hydrogen bond. Okay, so that's why the second point, it is found between hydrogen atom of one molecule. If you can consider hydrogen atom of one molecule and an electronegative element of another molecule. Okay, this is the hydrogen bond. So this bond is exist for hydrogen only with the another electronegative atom. Okay, now coming to the last one, it is just a force, but sometimes considered as the bond. Van der Waals. Van der Waals bond or Van der Waals forces is nothing but some electrical forces. Okay, so coming to this van der Waals bond, it is nothing but due to small electrical forces. Bond is due to small electrical or electrostatic forces other than ionic or covalent. Ionic or covalent. Okay, that means you can say forces between the atoms, that is attractive or repulsion due to some electrical forces. Okay, here you can note down these forces are force between two atoms due to attractive or repulsive interaction interactions other than ionic or covalent bond. Okay, these are very weaker bonds. Weaker bond. Okay, weaker bond. Now after this, we have to take one important table, that is nothing but some molecular shape and what is the bond angle and example. Okay, so sometimes we may get the question on that. So I want to give that one. If you can go with the molecular shape, and corresponding bond angle and example elements. Okay, no doubt. If you can consider a linear shape, linear means straight line. Linear means straight line. So for example, hydrogen bond H2. Okay, and CO2. CO2. So the bond, so they will ask the question that the CO2, the molecular shape is linear shape. The hydrogen, the molecular shape is linear. Okay, so like that. C2H2, ethene. In that, what is the molecular shape? That is also linear. How it will form? C, H. So that means linear shape. And in the linear shape, the bond angle is, if it is a straight line, means total 180 degrees. Okay. The second one, triangular planar. Triangular planar. So triangular means 3. Tri means 3. Okay. So then what will be the bond angle? So 360 by 3, that means approximately we have 120 degrees. 120 degrees. Here BF3, BCl3, BH3, like that. Okay, like that. And that means what? Triangular means, tri means 3. So one atom will be combined, form bond with the other 3. Other 3. So then the next one, tetrahedron. Tetra means 4 na? 4. Here the bond is, one angle is 109.5 degrees and 4, CH4, methane, very important question. So the what is the molecular shape of methane? That is tetrahedron. So whenever there is a 4 is there is a chance of tetrahedron, CH4, NH4, CCl4, like that. Okay. And the next one, trigonal bipyramid. Trigonal bipyramid. Okay, it may having two bond angles, maybe 90 degrees or 120 degrees. Okay, example PCl5, PF5. So tri means 3, bi means 2. So total we have the 5. So that's why PCl5, PF5, like that. Next, sixth one. 1, 2, 3, 4, 5. Octahedral. Octa means 6. Octahedral. Okay, so here bond angle is 90 degrees. 6 SF6. SF6 gas that is used in the circuit breakers. Okay, and the next one, sixth one, bent in shape. Very, very important. Bent in shape. Here also methane is important. Linear CO2 is important, very important for CO2. Shape of CO2 molecule. Bent in shape. Bent in shape here less than 120 degrees. Example SO2 and ozone O3. Okay. And the seventh, pyramid shape. This is also very important. Pyramid, example ammonia, less than 109 degrees 28 minutes. So here NH3, PH3, PCl3, all are pyramid shape. Here ammonia shape is important. And the next one, this is also very important, guys. A V shape or angular shape. V shape or angular shape. It is also less than 109 degrees 28 minutes. And the example water. Water has V shape. That is, if you can consider O, the hydrogen may be like this. So it is inverted V, or can denote like this also. Okay, so it is a V shape. H2O or H2S between the two nonmetals. And the next one, okay, next one, T shape. T shape. So it is angle 90 degrees. There is CLF3. CLF3. So here very important, CO2 linear shape. Okay, and after that we have one more important, methane, that is 4 means tetra. Okay, and ammonia pyramid in shape, and water molecule shape is V shape or angular shape. Okay, another bond is also there, coordinate bond, that is not that much of important. Okay, so sometimes they will also ask the question that ionic bond, another name of ionic bond. What is the another name of ionic bond? Electrovalent bond. Okay, electrovalent bond. So ionic bond is bond between metal and non-metals, that is due to transfer of electrons takes place. Sharing of electrons is nothing but covalent bond. Okay, which is the weakest bond? Van der Waals forces. Okay, and this table also important. Okay, students, we will discuss the remaining in the next session. All of you, thank you so much for watching, and don't forget to click on like option. So many students are not click on like option, guys. Students, if you click on like, then only this video will goes to so many. Otherwise, very less. If the less students watching, I may not get interest. Correct? So that's why please try to at least if you like the class, click on like. If you don't like, you can give the comment also. Sir, I don't like your video, so that's why I'm not click on like. Okay, I'm clicking on unlike. Yeah, your wish, yeah. Okay, but please respond at least. I can get the idea. So and so students are watching. Okay. Okay, students. Thank you so much, guys.